Good morning. Let's get started. We get to talk about indirect proofs today. And now this is about as opposite of the proofs that we have been doing as possible. And so we're doing them at the same time, just so that way we understand just a very different approach to proving something. And so really we got to come to this word indirect. And we got to think about, what does that mean? Well, of course, the prefix in means not, and the word direct, when you think about that, I almost defined it as, direct. So this basically means not direct, not straight to the point. And that would be a decent way to describe an indirect proof. But let me give you a slightly different version, maybe better example. If I was walking around and knew I had exactly one book in my backpack, and all my other books were sitting at my house on my table, I could, if I wanted to figure out what book I had in my backpack, I have two ways to do that. I have the direct way, which would be to open up my backpack and see what book is in there. Or I have the indirect way. The indirect way would be to look at my table and see what books are there, and by process of elimination, I can figure out what book must be in my bag. And that's how indirect proofs work. It's kind of more of a process of elimination of the things that cannot be, and whatever's left must be true. All right? To do indirect proofs, we have to really understand one word that we're going to see at different times, and it's called contradiction. And some of you might know what a contradiction is. When I asked for definitions of a contradiction, a lot of people gave me the definition of a counterexample. They said a contradiction is something that proves something else to be false, but that's not true. That's a counterexample. A counterexample is a piece of information or something that proves a statement to be false. Okay, but that's not what a contradiction is. A contradiction is a little bit different than that. I used to make the joke that my brother used to make fun of me for being an only child. Okay, that in itself is a contradiction, because I can't have a brother and I can't be an only child at the same time. So in itself, that is a contradiction. So what is a contradiction? A contradiction would be two, that's a little bit fat. Let's change that up a little bit. I would say that a contradiction is two statements that cannot both coincide. And another way of saying that would be they cannot both be true. Okay? All you have to do is turn on the news and watch different political figures in government. They will definitely have all sorts of contradictions. One person will say, well, the cause of this problem was this, and someone else will say, no, the cause of that problem was this other thing. And they literally contradict each other. And so a contradiction is just two statements that cannot both coincide. They can't both be true. And so it's not that one proves the other one false. It's just the two of them cannot be at the same time. All right, and so we're going to see some contradictions today. But before we even get there, I want to walk you through just another basic idea of kind of like indirect reasoning. We're going to do indirect proofs, but all of this kind of falls under the category of indirect reasoning, that idea of figuring something out in a non-direct way. So let's talk about this. Okay, here's exemple numero uno. And you do not have to write all this down. Please do not write all this down. Just pay attention. Okay, so we're looking at the directions here, and it says use indirect reasoning to figure out who is having dinner with Beth. All right, so here's the situation. Beth is having dinner with Sarah and one of Sarah's friends, either Libby or Kelly or Mercedes. Now, she knows who she's having dinner with. We don't know who she's having dinner with. So Beth is having dinner with Sarah and one of Sarah's friends, Libby, Kelly, or Mercedes. Beth orders a barbecue chicken pizza to share for dinner. And now here's some other facts that we know. We know that Libby is a vegetarian. We know that Mercedes is at the library. And we know that Kelly is allergic to mushrooms. So the question is, who is having dinner with Beth and Sarah? And so we look at this and we say, well, by process of elimination, the very first one here, we have Libby is a vegetarian. And why can't this work? Why is that no good? Well, Beth would not have ordered a chicken pizza if a vegetarian was coming for dinner. And so we know that one can't be right. Then we look at the second one. It says Mercedes is at the library. Well, if she's at the library, certainly she's not at dinner. And you might say, well, maybe she's coming to dinner later. Well, that's not what we're talking about. We're saying who's coming to dinner right now. And so if Mercedes is at the library, she ain't coming to dinner. So we can rule that one out. So by process of elimination, we get Kelly. But it's important for us to look at the rest of the information just to make sure that somehow Kelly doesn't get ruled out as well. And it says Kelly is allergic to mushrooms. But nowhere does this pizza mention that it's got mushrooms on it. So it's okay that Kelly's allergic to mushrooms. She's not a vegetarian and she's available. And so it must be Kelly. Beth is having dinner with Sarah and Kelly. So by process of elimination, we were able to figure out that it was Kelly. Okay? Now let's talk about when you're actually writing an indirect proof. An indirect proof always has 3 steps. That's the good news, that it always has 3 steps. Think about some of the proofs we've done with 6 or 8 or maybe even 10 steps. So an indirect proof will always only have 6 steps. The downside is because it's in written form, the steps sometimes are different. My steps might look a little bit different than your steps. And that can be frustrating for some people, frustrating for me, because I really like those 2-column proofs where it's like, hey, what I have is the same thing as what you should have. But with indirect proofs, it's sometimes a little bit different. So what I do want you to write down, hopefully you already wrote down the definition of the word contradiction. Hopefully you wrote down indirect proofs or indirect reasoning. And so now I want you to write down the 3 steps for writing an indirect proof. Okay? So step number 1. What's step number 1? Well, step number 1 is you have to assume the negation of what you are trying to prove. Now, this might sound kind of crazy at first, but you have to assume the negation of what you are trying to prove. Okay. Now, a lot of people get this one wrong. They miss what I'm saying. They don't hear me say assume the negation of what you're trying to prove. And a lot of people think I said state the negation or just negate what you're trying to prove. If I told you I wanted you to prove that it's raining outside, step 1 is not to say it's not raining outside. Step 1 would be to say, let's assume it's not raining outside. Okay? So it's always going to start with let's assume. All right? You're not going to state the negation because then you're trying to state a fact that's not true. But we're going to assume the negation. Okay? We say, well, let's prove that we're having pizza for lunch today. The first thing you would say is, well, let's assume we're not having pizza for lunch today. Okay? If you wanted to prove that today is not Thursday, the first thing you would do is you would say, well, let's assume that it is Thursday. Okay? And so that's the idea of an indirect proof. The very first thing, you're going to assume the negation. All right, let's talk about step 2. Step 2 is where we use that new word that we just learned. Step 2 is we lay out an argument that leads to a contradiction. Okay? So we find a contradiction. And a contradiction, remember, a contradiction is 2 statements that cannot coincide or cannot both be true. So we find a contradiction. All right? And a lot of times I'll say, well, you lay out an argument or you lay out enough facts that lead to a contradiction. Ultimately, we're trying to find a contradiction. I'm trying to keep these steps brief so you don't have to write much. All right, and the last one, step 3. Okay, what is step 3? Well, step 3 is that you conclude your assumption to be false, and so therefore what you're trying to prove must be true. That was a lot of words, okay? But we conclude that our assumption is false. And what we are trying to prove, so we conclude that our assumption is false, and what we are trying to prove, oh, that was an ugly G. Trying to prove, keyword, must be true. It's not that it might be true. It must be true. Okay, if we conclude that our assumption is false, by finding a contradiction, then what we are trying to prove must be true. Okay? So step one, assume the negation of what you're trying to prove. Let's assume, you just say the opposite. Step number two, you lay out a series of facts or argument until that leads to a contradiction. And step three, we conclude that our assumption is false, so therefore what we are trying to prove must be true. Think about that in this situation right here. You'd say, well, let's assume, if you were trying to prove to me that Kelly was the one coming to have dinner, you'd say, well, let's assume that Kelly's not coming to dinner. All right. And so what would that mean? The next step in your argument would be, well, that would mean that either Libby or Mercedes is coming to dinner. And you say, well, Libby is a vegetarian, Mercedes is at the library, and Beth ordered a barbecue chicken pizza. And so because Mercedes is at the library and Libby is a vegetarian, they cannot be coming to dinner. So therefore, we can conclude our assumption that Kelly's not coming to dinner is false and that she is, in fact, coming to dinner. And so that would be an indirect proof. And I know that was a lot of words, very fast, but since we had already talked about this situation, I figured we could do that. Okay, so let's try another example where we actually write a indirect proof. Okay? And so here's our indirect proof. If Gabby ran more than 10 miles over a 2-day period, not 10 miles in one day, but she ran 10 miles over a 2-day period, then she ran more than 5 miles on one or both of those days. Okay, I don't need you to write this down, but I want you to write an indirect proof. All right, so let's think about this. If Gabby ran more than 10 miles over a 2-day period, then she ran more than 5 miles on one or both of the days. So we're trying to prove this statement to be true. And so really the part that we want to negate is we want to negate the conclusion of the conditional. So that means I'm trying to negate, or I'm trying to assume the negation of this part right here. I'm trying to say that maybe that didn't happen, okay? So we're saying if Gabby ran more than 10 miles over a 2-day period, we're not negating that. That happened. We're trying to prove that she must have ran more than 5 miles on one or both of the days. Well, let's do this, okay? So we're going to start out with that fancy sounding saying, let's assume, okay? Let's assume what? Let's assume that Gabby ran. Now, here's where it's tough. A lot of people are going, man, I just put in the word not and take out the word not for negation. But when we hear phrases like more than or less than, we need to not just put in not, but we need to think about what is the other. So instead of saying, let's assume that Gabby did not run more than 5 miles, let's just flip that around. Say, let's assume that Gabby ran less than 5 miles. And here's the other part that people struggle with. They wanted to just kind of finish it out with the on one or both days. But think about that statement. Let's assume Gabby ran less than 5 miles on one or both days. Well, if she ran less than 5 miles on one of the days, maybe the other day she ran way more than 5 miles, and she could still have run more than 10. So that doesn't work. We have to come up with a statement that we've got to find to not be true. Remember, we're assuming the negation, and we're trying to prove that statement false. So if we just say, let's assume she ran less than 5 miles one of the days, well, that statement could be true. We're never going to get a chance to prove that that's false. So we have to say, let's assume that Gabby ran less than 5 miles each of the 2 days. Okay, let's assume that Gabby ran less than 5 miles each of the 2 days. So it doesn't matter. Both days, she ran less than 5 miles. Okay? Now, let's try to lay out a little bit of, so that was step one. Let's lay out a little bit of an argument to try to get us to a contradiction. Okay? So let's assume that Gabby ran less than 5 miles each of the 2 days. But what do we know? We're saying, but if she ran more than 10. Okay? So we go, wait. So, but we don't want to just automatically go, oh, well, that can't be. Let's assume that Gabby ran less than 5 miles. She didn't. She actually ran more than 5 miles. We don't want to do that. Let's walk down and figure out what would we know next with this argument. If we did know that Gabby ran less than 5 miles each of the 2 days, then we would know, let's assume that Gabby ran less than 5 miles each of the 2 days. Then what? What would we know? We would know that if that were true, then Gabby, what would be her total? would have run, if she ran less than 5 on both days, then if that were true, then Gabby would have run less than 10. Less than 10 miles total. But what do we know? We're going off the basis that she ran more than 10 miles. Okay? And so, but we're saying, but we know Gabby ran more than 10 miles. Okay, and so then where are we at? We're now at step 3. Okay, because there's our contradiction. We found something that led to a contradiction. We said, let's assume that Gabby ran less than 5 miles each of the 2 days. If that were true, then Gabby would have run less than 10 miles total. But we know that Gabby ran more than 10 miles. There's our contradiction. So now we're to step 3. Okay, so we can conclude our assumption to be false, and then we go, let's kind of put it all together. Again, we're going to use a fancy sounding word. Therefore, Gabby would have to run more than 5 miles each of the 2 days, right? Therefore, Gabby would have to run more than 5 miles each. I'm sorry, that's not right. Not each of the 2 days. Gabby would have to run more than 5 miles one or both days. Okay. Now, I know that might be kind of confusing. This was kind of a crazy thing. This is a really weird and different idea compared to what we've been doing. This indirect proof. Remember, we're kind of ruling out all the things that are not possible.
Following senior girls to report to the music building: Allie Nobles, Casey Ray, Michaela, Cadence, and Kaylee.
All right, now we got that announcement out of the way. Let's get rolling. Okay, so we have completed this. So now let's try one last thought. Okay, so use indirect reasoning to make a conclusion. Okay, so our statement says Morgan works at the cafeteria every Saturday morning. He did not work at the cafeteria this morning. Okay, so what would be some indirect reasoning we could do? We could say, if he did not work at the cafeteria this morning, okay, if he had, maybe we'll start that way. If he had worked at the cafeteria, then what would we know? If he had worked. Now, it said he did not work, but let's kind of go with the opposite. Let's go with the negation of that. Now, we're not doing a 3-step proof here. It just said, hey, use a little bit of indirect reasoning. We're not doing a whole proof. Just use a little bit of indirect reasoning. So for this one, we're saying Morgan works at the cafeteria every Saturday morning. He didn't work at the cafeteria this morning. Well, let's go with the opposite. If he had worked at the cafeteria this morning, then what? Then we would know that it is Saturday. Okay, we would know that it's Saturday because he works there every Saturday morning. However, Morgan did not work. We saw that Morgan did not work at the cafeteria this morning. He did not work at the cafeteria this morning. Let's make sure I kind of got most of that right. Okay, if he had worked at the cafeteria this morning, then we would know that it is Saturday. However, Morgan did not work at the cafeteria this morning. Therefore, we know what? We know it is not Saturday. Okay? So here's us using a little bit of indirect reasoning. This idea of indirect reasoning is we're ruling things out. If we know that Morgan works at the cafeteria every Saturday morning, but he did not work at the cafeteria this morning, we kind of automatically know. We say, well, we know then it can't be Saturday. Well, why? Because if he had worked at the cafeteria this morning, then we would know that it is Saturday. However, Morgan did not work at the cafeteria this morning. Therefore, we know it is not Saturday. Okay? Now, I know that this stuff is going to be a little bit challenging and a little bit different, but I'm going to have you do the try-its in the book. And the reason why I'm having you do those is because there is an example before each try-it that almost spells out exactly how you should be doing it or the things you should be thinking about. And so that's what we're going to do. So for the remainder of your time today, I want you to open your books and turn to page 58, 59, and 60, and you are going to do numbers 1 through 4, or the try-its. All right. I hope you all have a great day. Enjoy it, and we'll see you later.